This section is about congruent triangles. In this section, you will learn how to apply the various triangle congruence theorems to determine if triangles are congruent, use triangle congruence theorems to find side lengths, and write appropriate congruence statements. The definition of congruent triangles. Congruent triangles have the same size and shape. If two triangles are congruent, the three angles of one triangle will have the same measure as the three angles of the other triangle. The three sides of one triangle will have the same lengths as the three sides of the other triangles. Here is an example of congruent triangles, and we're told that triangle ABC is congruent to triangle EFD. Notice that there are three pairs of corresponding angles. Angles A in one triangle and E in the other are congruent, as are angles B and F. Similarly, angles C and D are congruent as well. Segment AB is congruent to segment EF. Segments AC and ED are congruent, as are segments BC and FD. Triangle congruence statements. If we were simply naming the two triangles in the last slide, we could call them triangle ABC or triangle DEF. However, if we want to indicate congruence, we want the letters to match up so that congruent vertices of the triangle appear in the same position in the congruence statement. If we call the first triangle triangle ABC, we note that point A goes with a 90-degree angle. The point that goes with a 90-degree angle in the other triangle is E. Since A is written first when describing the first triangle, we want E to be written first when describing the second triangle. For similar reasons, if we want F to be written second and D to be written third. We note that angles A and E match and are called corresponding angles. Angles B and F are congruent and are called corresponding angles. Angles C and D are congruent and are corresponding angles. The sides can be congruent as well and are corresponding. For example, sides CB and DF have the same length and are called corresponding sides. Here are some triangle congruence theorems. The first one is the side-side-side postulate. The side-side-side, or SSS postulate, tells us that if all three sides of one triangle are equal in length to all three sides of a second triangle, we may assume that the two triangles are congruent, even though we know nothing about the angle measures. A second triangle congruence theorem is the side-angle-side postulate. The side-angle-side postulate tells us that if two sides of one triangle and the angle between them are congruent to two sides of the second triangle and the angle between those sides, then the two triangles are congruent. Even though we know nothing about one of the sides and two of the angles, we may still assume congruence. Here is an illustration of the side-angle-side postulate. Notice that for the side-angle-side postulate to apply, the corresponding angles must be between the pairs of corresponding sides. You will also notice that to indicate congruent side lengths, we use dashes, and to indicate congruent angles, we use arcs. The angle-side-angle postulate tells us that if two angles of one triangle and the side between them are congruent to the two corresponding angles and the side between them of the second triangle, then the two triangles are congruent. Yet another congruence postulate is the angle-angle-side theorem. The angle-angle-side theorem guarantees that two triangles would be congruent if two consecutive angles and the side immediately after them are congruent to the corresponding parts of a second triangle. We also have congruence postulates applying to right triangles only, meaning that the triangle has a 90-degree angle. These two triangles are the hypotenuse-leg theorem and the leg-leg theorem. They follow from the Pythagorean theorem and the side-side-side postulate, by the way. The first is the hypotenuse-leg theorem. This theorem states that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of a second right triangle, the two triangles are congruent. The second theorem is the leg-leg theorem. This theorem states that if two legs of one right triangle are congruent to the two legs of another right triangle, the two triangles are congruent. Warning: there is no such thing as the side-side angle postulate. A geometry teacher told my class to realize what SSA written backwards is. That is what you make of yourself if you believe in the side-side angle postulate. Recognizing congruent triangles. When a parallelogram, rectangle, or square is divided by a diagonal, the two resulting triangles are congruent. Recognizing congruent triangles drawn into circles. Given a circle with center A, triangle ADE is congruent to triangle ABC by side angle side. Segments AD, AE, AB, and AC are all congruent because they are radii of the same circle. Recognizing congruent triangles drawn into circles. Given a circle with center at A, triangle ADE is congruent to triangle ABC by side angle side. Segments AD, AE, AB, and AC are all congruent because they are radii of the same circle. And remember that all radii of the same circle are congruent. Also, angle BAC and angle DAE are congruent by the theorem of vertical angles. Here is example 1. Assume that segments DE and BC are both parallel and congruent. What side of triangle ADE is congruent to segment AC? By alternate interior angles, angle D is congruent to angle C, and angle B is congruent to angle E. Therefore, the two triangles are congruent by side angle side. Match the corresponding angles to form a congruent statement. Triangle ABC is congruent to triangle AED. Therefore, AC corresponds to AD, and they are congruent. Here are some practice problems for you to try. Pause the DVD after each problem. When you have finished working, come back for the answer. What side on triangle DEF is congruent to AC? The answer is DE. Note that AC is the segment between the angles with 1 and 2 congruence marks. Therefore, you are choosing the segment on the other triangle that lies between angles of the same size. And those angles would have both 1 and 2 congruence marks as well. Practice problem 2. Given the rectangle below, what postulate proves that triangle ECB is congruent to triangle EAD? The answer is the angle-side angle theorem. Remember that BC and AD are parallel lines because rectangles are special cases of parallelograms. The diagonals are transversals. By alternate interior angles, angle BCE is congruent to angle EAD. Similarly, angle CBE is congruent to angle ADE. CB is congruent to AD by the definition of rectangles. Therefore, the two triangles are congruent by angle-side angle. Ramsey stands at point D on shore and sees a ship at point A. He measures the angle between himself and the ship as 60 degrees and measures a 60-degree angle on shore. Point C is a point on shore that is directly across from the ship. The line from point D to point C measures 120 yards. Line segment AB makes a right angle with the shore. What postulate will prove that triangle ADC is congruent to triangle BDC? The answer is angle-side angle. The line AB makes a right angle with the shore. Therefore, both triangles contain a right angle. Both also contain a 60-degree angle. The shoreline forming a side of both triangles is the same and is between the two triangles. Therefore, the two triangles are congruent by angle side angle. Practice problem 4. Refer to the diagram from problem 3 on the left. Use the facts about special triangles to find AC, the distance from ship to shore. The answer is 120 square root of 3. The triangles are 30, 60, 90 triangles. The shortest side is opposite the 30-degree angle and is 120. Note that the figure is not drawn to scale. The distance from ship to shore is opposite the 60-degree angle and is 120 square root of 3. Segment AB is congruent to CD, and these segments are parallel as well. What line is congruent to BE? The answer to practice problem 5 is EC. Angles B and C are congruent by alternate interior angles. Therefore, the side between angles E and B will be congruent to the side between angles E and C. Practice problem 6. In the drawing below, segment CD is the perpendicular bisector of segment AB. What theorem could you use to prove that triangle ACD is congruent to triangle BCD? The answer is the leg-leg theorem. AC is congruent to BC by the definition of bisector. Because CD is a perpendicular bisector, it forms a right angle with the base. Therefore, we have a right triangle. Also, CD is congruent to itself by the reflexive property. Therefore, there is a right triangle with two pairs of congruent legs. Practice problem 7. Given that segment XY is perpendicular to WZ and that WY is congruent to YZ, what theorem would you use to prove that triangle WXY is congruent to triangle ZXY? The answer to practice problem 7 is the hypotenuse leg theorem. Because XY is a perpendicular to the base, it forms a right angle to the base. We are told that the two sides WY and ZY are congruent, and XY is congruent to itself. Hence, we have a right triangle with the two hypotenuses congruent. The common leg XY is congruent to itself. Practice problem 8. The center of the circle is at A. What triangle congruence theorem could you use to prove the two triangles in the figure are congruent? The answer is the side angle side theorem. The two pairs of radii are congruent, and the angles between them are vertical angles and are therefore congruent. Practice problem 9. Given the circle with center at A, and it's the same figure we used in the previous slide, and we're given that CE is congruent to DF, what triangle congruence theorem could you use to prove that the two triangles were congruent? The answer to practice problem 9 is side, side, side. In this case, the answer to practice problem 9 is side, side, side. In this case, the bases of the triangle would be congruent, as well as the radii forming the other sides. Of course, you could still use side angle side. And this completes the section on congruent triangles.